Hi guys, today we're going to have a look at 12D, which is where we're looking at graphing a inequality. And so far we've looked at if x is equal to 4, if x is greater than 4. Today we're looking at when we've got two values, x and y, being equal to or greater than 15. So when we look at this inequality, we're looking at equal to or greater. So the line that we draw on this graph will be a straight filled in line because it includes 5x plus 3y is equal to 15. So the first thing that we need to do in order to be able to graph this is to find the x and y intercepts. That gives us a starting point and some starting data that we can use, some starting coordinates. So the first thing that we can do is set up a table of where we'll record our coordinates. So we want to find out that when x is equal to 0, what will y be? And that will give us a coordinate of 0 and a y coordinate. And we want to find out that when y is 0, what will x be equal to? So that will give us a second coordinate in which the y-intercept is, the y value is 0, and that will give us our x-intercept. So the way that we need to do that is by substituting in the values of x and y when they are equal to 0. What I mean by substituting is putting it into this equation. We're going to substitute in when x is 0 and substitute in when y is 0. So when x is equal to 0, and we put that 0 into the equation in the place of x here, we would have 5 times 0 plus 3y being equal to 15. And we know that 5 times 0 is 0. So we can remove that from our equation. So we get left with 3y being equal to 15. Whenever we do algebra, we want y by itself. We want to know exactly what y is without being multiplied by 3. How would we do that? We divide by 3, which means we divide the other side by 3. This gives us y being equal to 15 divided by 3, 5. So we know now that when x is 0, here y will be equal to 5. So we have our first intercept, we have our y-intercept. Our second one, as you can probably guess, will be when y is equal to 0. And we use 0 in place of the y value. So we have 5x plus 3 times 0 being equal to 15. And we all know that 3 times 0 will be nothing. So we can remove that from our equation. This leaves us with 5x being equal to 15. We want x by itself. We do not want it being multiplied by 5. We divide by 5 on this side, which means we divide by 5 on the other side. X is then equal to 3. So we now know that when y is equal to 0, that means that x will be equal to 3. And that gives us our second coordinate that we can plot on the graph. So we have 0, 5 and 3, 0. So we can now go ahead and actually put those onto the graph, and that's the second thing that you need to do. We need to graph the line of 5x plus 3y is equal to 15. The way we do that is by using our coordinate points. So we know that when x is 0, right, so we're going to move up and down here. We're not moving anywhere else left or right. Y is going to go up 5. 1, 2, 3, 4, 5. So we know that this is our first point. 3, 0. The y value is 0, so we're not going to move up. We are going to move right 3. So 1, 2, 3. Okay, so now we have two coordinates in, and now we can actually graph the line in between them. It's given us enough data to be able to do that. So So we've now graphed this line, and we need to label this line, which is 5x plus 3y is equal to 15. That's our line. And the reason that it is not dashed, the reason that it is solid, is because this inequality is asking for equal to or greater than. It is asking for us to include the values along this line, the values that are equal to this equation, including the ones either side of this region, depending on which region we're looking for. So that's the next thing we need to do. We need to find out what region we're looking for. Are we looking for above the line, up here, and all these values up here, or are we looking for below the line? Right? We're looking for either equal to or greater than, or equal to or less than. Right? So this is what we need to test. We need to find out exactly what area we are looking at. So the way that we do that is that we use a test point. And the most common one is the origin. We'll commonly use 0, 0. That's our O for origin. We'll commonly use 0, 0. That will give us an indication as to if the origin satisfies this equation or this inequality. It means the feasible region will be on this side. If that isn't true, it means that the origin is not included. So it will be on this side. So let's substitute in the values. So when x is equal to 0 and y is also equal to 0, we now get an equation where it's 5 times 0 plus 3 times 0, an inequality, where 5 times 0 and 3 times 0 is equal to or greater than 15. And we know from before that 5 times 0 is 0, and 3 times 0 is 0. So the ending inequality is that 0 is equal to or greater than 15. Now we know that's not true. We know that 0 is not equal to or greater than 15. So in this case, we can say that the region does not include the point 0, 0. So if we were deciding which side of this we were going to include, the coordinate 0, 0 is not included. So we know that this side is not to be shaded. Right? So we know that we need to actually shade the other side. So we're going to shade this side, or highlight in my case. And probably better than I just highlighted. So now we've shown our feasible region. We've shown the region that is satisfied by 5x plus 3y is equal to or greater than 15. The last thing that we need to do is label it and say this is 5x plus 3y is greater than or equal to 15. Okay, and that includes the boundary of this line that we have graphed. Okay, make sure that you do label these as well so that you can tell exactly what you have included.